Good afternoon. Hope everybody had a good lunch and all woke up. Scott, that was a really interesting topic, and I think we can all learn a lot from that. I'm going to talk about something a little bit different. This is more of an application. I'm going to actually make a very simple point, and I'm going to take a while to get to it and to provide you with kind of the context and the rationale for me wanting to make that point. So what I really want to express is that the National Weather Service, and my office in particular, has a great deal of interest in the development of a community modeling system that we can use operationally in the Sacramento-San Joaquin Delta. So I find it instructive before I launch into these sorts of things that people understand kind of our mission. You know, why do we do what we do? I think there were some comments about that earlier in the day in terms of motivation. The principal mission of the National Weather Service's Hydrologic Service Program is protection of lives and property. It's really pretty simple, and it's actually, I believe it's a pretty noble enterprise. Trying to keep people alive and keep their stuff from getting ruined is a good reason to come to work every day. And then as a secondary and actually as a growing part of our mission is to provide information for the economic and environmental well-being of the nation. And when we get into periods of drought in California like we're currently experiencing, pressure on water resources and the information that we can provide to help decision makers becomes a lot more valuable and is certainly part of our mission as well. And if you hadn't heard, the Weather Service in general is really migrating away from this notion of just pitch a forecast out there and hope for the best to creating what we're calling a weather-ready nation and completing the forecast and really working with our customers and partners to make sure that that we're providing the right kind of information that needs to be that can be utilized for sound decision making to mitigate hazards and to understand how those decisions are made so that we're meeting those properly, and this is all part of that, certainly. So we have in the Weather Service, we have 13 river forecast centers like the one that I represent in Sacramento, and you can see that that's circled in red. We have 122 weather forecast offices, which are our primary connection to the public, and we have these 9 centers for environmental prediction, which you've heard of under different names like the Hurricane Center and the Severe Storm Center and the Space Weather Center, etc. So if you look at my little office in Sacramento, we have 14 people that are attempting to provide hydrologic service to an area of 245,000 square miles and lots of people. We have a little bit of an unusual arrangement in my office in that we have an integration of state and federal staff. The California Department of Water Resources and their Division of Flood Management are part of our operation. They're on our floor every single day. They work with us throughout floods and droughts, and it's really a nice example of how we can be unstovepiped, I suppose, and work together, and it's worked out really well. We've been doing that for in excess of 50 years. So if we just kind of look briefly at how one might generate hydrologic forecast guidance, you have some kind of river forecast system. These are our modeling systems. You have hydrologists that are running them. You got observing systems. These things don't come calibrated, so we got to calibrate them. And then you have to drive them with some sort of forecast, precipitation and temperature forcings. Those come from something in our unit that we call the Hydrometeorological Analysis and Support Unit. These are meteorologists that have the simple task of figuring out how much it's going to rain and what the temperatures are going to be, which is among the most difficult. And then out from that process would flow flood forecast guidance, short-term, and then also probabilistic information, which is a domain that we're really actively pursuing on short, medium, and long-range scales. So if you look at our meteorological operations, we're integrating information from our national centers, from our weather forecast offices in our areas, some of our own information, and producing that 5-day, 6-hour time step interval precipitation, temperature, and snow level. Snow level's pretty important in California for managing these big storms, and those go into the hydrology model. Carl mentioned earlier that we're using a system called the Community Hydrologic Prediction System. Its foundation is in the flood early warning system that was developed by Deltaris in the Netherlands, something that we embarked on. When did we start on that? It must have been about 2008 or so, yeah, and worked through a process of migrating all 13 of our river forecast centers into that environment. And it really has provided a much better context for us being able to integrate other models than we have typically included in our suite of operations, most notably those from the Corps of Engineers, but others, and provided a really nice interface for our forecasters to be able to understand what's going on within the modeling system itself. So that's just an idea of within our current implementation of FUSE, this Community Hydrologic Prediction System, we can hang any number of models. These are the typical ones that we're operating in our RFC forecast system today, but they could change. And to give you an idea of the sorts of interfaces that our forecasters have available to them, it's really been great because in the past, you can run a model, and if you just really can't see inside of it and what's going on with the model states and the inputs and how things are transitioning and how different states or inputs compare to historical climatology, you can't really tell what's going on. And this new forecasting environment has really helped open that up to a great degree. And interestingly, our old forecast system, which was Fortran-based, ran a lot faster than this Java-based system. But this is so much more effective in helping people make decisions about what's going on that we can produce forecasts 2 or 3 times as fast with this system because we're not fussing around and couldn't really understand what was going on with the models in a previous environment. So we can use these in a deterministic fashion, single value fashion. That's what's traditionally been done in hydrologic forecasting for a long time. So we can run, again, this modeling system with inputs and we've got a data ingest and QC process. By the way, that takes a lot of effort. If you've never been involved in operational forecasting, these data just don't arrive in your database all shiny and nice. They have to be looked at, and they have to be adjusted, and they have to be discarded. And because, if you put a bunch of junk in your model, then you know what you get back out. And we're always, again, updating, current conditions. We know what's in the reservoir. We know what's in the stream flow. We're modeling snow water and soil moisture, et cetera. And we can kick out a 5-day forecast of stream flow that our partners and customers and users can utilize to make decisions about emergency preparedness or resource management or recreational activities or whatever. And those are currently provided at about 275 locations within our roughly 2-state area. They're done twice a day in the wintertime, once a day in the summertime. Not much happens here in the summertime. We have this big dry spell, and so it's not quite as important. When we do get into a high water situation, we kick up to 24-hour coverage, and we'll be issuing these 4 times a day. Whoops, wrong way. So we can also run that exact same system in an ensemble mode, and I would assume most of you are familiar with what ensembles means, so you can exercise your current model states with a whole suite of scenarios of future forcings, and then that are importantly equally likely, and you can generate a set of future scenarios that you can then analyze over any time domain to help you tease out other sorts of information. So we can do that as well. And we're running about 200 locations currently. Those run out to a year in advance. You say, wow, a year in advance, that's a long time. certainly the skill in the weather predictions is long gone before you get a year into the future, but there is a lot of information in the model states. And so, for example, if you're looking at making a projection of stream flow from the Sierra, and you have information in the snowpack and in the snow water, or in the soil moisture, there's actually a lot of information that can help you make a water resources forecast, and we've been doing that for quite a while. And our current methodology includes 14 days of weather as reflected in the global ensemble forecast system. And just to give you an idea, the sorts of products that we can generate from that. It might be a seasonal water supply forecast. It could be a histogram of expected monthly flows or daily flows or water year flows, or it could be, in the case of the this plot here, a 10-day accumulated inflow forecast for reservoirs, which would be of interest to our water management partners. So where does all this information go? For the emergency services portion of this, we funnel our forecasts through our weather forecast offices. They're kind of our boots on the ground liaison with local emergency management concerns, and they're the ones that are going to be issuing the public warnings for us. But we also work really closely with a whole suite of water management, flood management, and utility interests, and they're the ones that are getting our water resources or other information to help them make better decisions about water and what they're trusted with. So that's kind of the background on what we do and how we do it and why we do it. And then I'll continue by saying this is what we currently do in the Delta, and I'm honestly a little embarrassed to show you how we do this and how little we do. And one of the reasons that I was interested in being here today was to be able to address this group and let people know that we're interested in doing something better, and we definitely need your help to do that. So the methodology that we've used in the Delta I think was developed when I was in high school, and I'm pretty sure that's when and that was a while ago. And we only provide service for 5 locations. You can see them listed there. And we only do turning point forecasts, okay? Highs and lows for the next 2 days, and it's just staged, and we do it once a day. And if and when a levee breaches in the Delta, which happens periodically and is bound to happen again, then it's guesswork. And everybody scrambles. So we really want something that can do much better than this, and I'm certainly convinced that that is out there. This is what we would like to do. This is where I would like to go. I don't want to just make forecasts for 5 locations. I want to make them everywhere. You know, there's nothing magic about Mallard Island and Venice Island and Antioch and Rio Vista, but there's lots of concerns throughout the Delta, and people have a need for information everywhere. We need to be doing this on an hourly time step at a minimum, and we need to be talking about more than just stage. We certainly need to be doing stage flow, temperature, and salinity. So even from a water quality perspective, there's a lot to be gained by doing this. And we need to go not 2 days into the future, but at least 5. And we need to be doing this certainly daily, if not more often, as things develop. And then we need to be able to handle levee breaks. And we need to be able to do that objectively, and we need to be able to do it quickly so that we can provide the sort of decision information if we were to have another levee break, and we probably will. I'm sure we will eventually. How will that affect the salinity? If a really large island floods, and there's a lot of information that's needed in those situations. So how are we going to do that? And so this is why I believe that this sort of workshop and topic is really interesting. The notion of a community model concept is very appealing to me, and I hope it's appealing to you, because as we sit in this little operations bubble down here, I'm not really interested in just integrate or developing a new model that somebody's going to stand here, 45 years from now and say, well, this model was developed when I was in high school. What I want is a continuous injection of new science and technology into my operations, and it's very difficult for me to do that by myself. It's like impossible. But I see this connection between the research community and something that we really haven't talked about earlier today is the planning community. There's a lot of people that are running planning models in the Delta to figure out, what happens if we do this, what happens if we do that. They need models, right? So you have the research community, you have the planning community, and then you have the operations community. And we have pretty rigorous requirements for run times and reliability and all that kind of stuff that may not be quite so important to some of the other uses, but so the model may need to adapt to that a little bit, and I'm sure we can work that all out. But it seems like there would be and there should be a great deal of interest in the research community having that connection to operations, for you to be able to go to the grant providing organizations and say, hey, we've got a connection to the research, to the operations application, so that they can make a difference in how the resources are managed in the future, and the planning community would be in the same boat. So it seems like if we work together, that could work out really nicely for everybody. So what makes my office the appropriate office to run the operation? So I thought about that, and I thought you might be interested to know why. It's my opinion. We run a 365-day operation. There aren't many folks that do that are willing to be in the office issuing forecasts at 2 o'clock in the morning on Christmas. But we're there 24/7 as needed, and we have 50 years of experience doing that. We're already forecasting all the freshwater flows into the Delta. So we've got those models established. We know how to run them. We can provide that sort of information that's going to be needed. And we're well connected to all the water management agencies that are active in the area. And then we're in a position where we can really fully integrate NOAA's weather expertise into the process. Not to be overlooked, we're an honest broker. Our goal is to put out objective, unbiased information. So we don't have any conflict of interest when it comes to managing the resource. The numbers are the numbers, and they provide insight, right? But we don't profit or fail to profit on the basis of the forecasts that we issue. So I think that's really important. We have very high operational reliability. We don't run models that blow up, and we always have to be able to issue information, and we've pretty much established that reliability. And we have really solid connections to the sorts of partners that you can see on the screen here. So I think that's it's a reasonably good justification for why I believe that we need to be doing that. And we could certainly do that in a partnered fashion. So in summary, we're ready to engage on this. If this community can come together and we can figure out some sort of pathway from research through planning to operations, we're all ears and really would like to do that. As I say, we're not in a position to develop this ourselves. It's going to take us. It would take us a long time to do that, and the results I don't think would be what anybody would want anyway. And we really want to be part of this research to operations framework and bringing that into real-time operations. So that concludes my remarks, and can we take questions? Okay. Thank you.
Yeah, we have time for one question. Thank you.
Over here.
I was wondering how much long-term forecasting you do.
How much what?
Long-term, like seasonal?
Oh, sure. Okay. The question was, how much long-term forecasting do we do? So we run all of our hydrologic models on a daily basis out for a year in advance. We don't go beyond. Is a year long-term? I mean, we're not making climate projections You could, but we're not currently doing that. But they do run out for a year. They, at current time, we're using just 2 weeks of the weather forecast in a balanced fashion. We're not taking it at face value. It's the degree to which we weight the weather forecast is proportional to the skill that it's historically exhibited. So by the time you get to the end of that 2-week period, there's not much forecast left because it's not all that great at that point. And then beyond 2 weeks, we're using climatology. In other words, what's been experienced before. We're trying to work in greater climate forecast system modeling, but it's not particularly skillful. So there's really higher risk associated with using it than not using it at this point. So yes, we're running out for a year. Mm-hmm. Yep. Thank you.